So now we will study about torque. What is torque? What is torque? What do you mean by torque? Anybody? Force on a rotational motion. Yes or no? Rotational motion. Yes. Yes or
sir.
no?
Yes, sir.
Just for example, I am taking a cardboard. Okay. You are pulling like this. Rishabh is pulling this cardboard like this, and Harsh is pulling this side. Can you tell me what will happen to this cardboard? It will either go this side or it will go this side, depending on the amount of force Harsh or Rishabh is pulling. Yes or no?
Yes, sir.
If Harsh and Rishabh pulls in the same force, then probably the cardboard will be stationary. It will not move. And if they apply higher and higher forces, it may happen that the cardboard may break from middle. Yes or no? These are the possibility. Yes or no? Agree with me or not?
Yes, sir.
Yes, sir.
But now, second thing came. Swarup came into picture and started pulling in this direction. And Dhruv came into picture and started pulling in this direction. Harsh is pulling in this direction. Same 2 Newton, 2 Newton, 2 Newton, 2 Newton. Can you tell me what will happen in this scenario?
So the body will not move
Why?
because the force is equal, right? So how will the body move?
Who said force is not equal? Force is equal, okay. Force is equal. So what?
That's what I'm saying. The force is equal. So the force is negligible, right? So the body will be stationary.
So here, if you see, the line of action is 1. Okay. Line of action is 1. So these two forces cancel out. It is as good saying that Harsh and Rishabh are not pulling. I will neglect this, both of them. They are not in picture. Understood? Then what is there?
Yes.
Then what is there? Now, if you see, Dhruv is pulling in this direction. Rishabh is pulling in, Swarup is pulling in this direction. So what will happen? It is basically saying that there is a wire. I am pulling in this direction and somebody is pulling in this direction. What will happen? Just keep your pen, no? Have you played a rotational pen game? You try to rotate it, no? If you want to rotate it, you will apply a force here, this direction, and you will apply another force in this direction. Then this pen will rotate. Yes or no?
Yes, sir.
That means, what is torque? Torque is basically rotating force acting in opposite direction. That's called couple. Couple matlab, here also you are applying a force and here also applying a force. If both forces are applicable in this, the line of action is 1. The pen will not move. But if you see, the line of action is here and this line of action is here. I'm applying in both opposite direction. Then this pen will rotate. So here the cardboard will rotate. Maybe this will come this side, this will come that side. So maybe if it is A and other side is B, then it will become what? It will become B and other side will become A. This will rotate. And this concept is used in electric motor. All the fans, grinder, okay, in pump, water pump, okay, even your turbine, everywhere you are using the same method, electric motor, where current gets converted into mechanical energy to do your work. What does motor does? Motor will give you energy. It is making your work easier. If you want to grind gravels or you want to grind dal, you want to make powder. So what do? You give current, electric current to a grinder. Then when you on your switch, then only the grinder will rotate. Yes or no? Yes or no? So the concept of motor comes from the torque on a current loop. So we will study about that. Next topic is electric motor. How does a motor rotates? What are the main principle of the motor? What is the construction of the motor? We will talk about that. Is it clear to all of you?
Yes, sir.
Yes, sir.
So write down the definition of motor. What is a motor? Write down. Electric motor is an instrument. Electric motor is an instrument. Okay? Or a device that converts electrical energy into mechanical energy. Converting electrical energy into mechanical energy. In simple terms, it's a device used for producing rotational energy. Clear?
Yes, sir.
So what is the main principle? Write down the principle. The electric motor works on the principle that when a coil is placed in the magnetic field, when the coil is placed in a magnetic field and the current passes through it, it results in rotation of the coil. It results in rotation of the coil. आया समझ में? आया समझ में? Guys, clear or not?
Yes, sir.
Yes, sir. Clear.
All of you, Harsh, clear? Swaroop?
Sir.
So what is the main? I will just teach you the main principle. So motor will be like this. If you see small motor, it will be like this. So there will be two horseshoe magnet. And inside there will be a coil which will rotate, and because of that you will rotate. So if you want to postmortem the what do you call that? The motor, you will have two poles, north pole and a south pole. And there will be a, I am actually showing towards you, so I am showing like this. Normally it will be like this. How? मतलब कैसा रहेगा पता है? ऐसा रहेगा और वो कॉइल ऐसा रहेगा, ठीक है? वो रोटेट करेगा, ऐसे घूमेगा. You will see. So I'm just explaining you right now. In this way you understand. Okay? So ये कॉइल है, ये करंट, ये तुम्हारा उसको बोलते हैं आर्मेचर. क्या बोलते हैं इसको? आर्मेचर. और ये एक करंट लूप है जहां पर करंट ट्रैवल करता है. ठीक है? तो ये नॉर्थ पोल साउथ पोल है, तो मैग्नेटिक फील्ड कैसा रहेगा? In this direction, yes or no? Yes or no? Huh?
Yes,
Yes,
sir.
Current is going like this. So current is in this direction. First, let us talk A, B, C, D. So let us consider AB. Okay, let us consider AB. In AB, current is upward direction. Yes or no? Current is upward direction. So what will happen? So what will happen to the magnetic field? Which direction it is? Which direction? Towards your right. Yes or no? Towards your right.
Yes, sir.
Then what will happen to the magnetic force? Which direction it should be? नीचे की तरफ.
Downwards, right?
बिल्कुल. Very good. Downward
So it
direction.
will move clockwise, sorry.
Very good. If you talk about here, it will be up. ये नीचे की तरफ मतलब into the plane. This should be out the plane. मतलब ये कैसे घूमेगा? ऐसे घूमेगा. ये कुछ समय के बाद ऐसे दिखेगा. उसके बाद currently AB is topward. जब घूम जाएगा, then it become what? BA हो जाएगा. So this will keep on rotating, and this works on the principle of what? Fleming's left-hand rule. समझ में आया? समझ में आया? ये side में, in this side, the force is acting downward direction, and this side force is acting upward direction, and it's a torque. It's a torque. समझ में आया? That's how it is rotating. It's basically what we understood about the cardboard, where somebody is pulling this side, somebody is pulling that side. Dhruv is pulling outward this direction, and Swarup is pulling this direction. So it is rotating, and continuously the current is there. And we will understand about various other factors, commutators, split rings, carbon brushes. Okay, and that will be easy. If I want to show you a demonstration, then we will understand. Okay, let us see the demonstration, then you will understand. Because three-dimensional, it is a little difficult to teach in offline through this thing. So I want to show you a YouTube video, and then we will discuss more about that. Till now, is the concept clear?
Yes, sir.
So that means the electric motor rotates when? Till you are giving current. Immediately when you switch off current, because there is no current, there is no what? Magnetic force. Understood? Understood?
Yes, sir.
Rishabh, understood or not?
Yes, I understood.
Working principle of DC motor. Working principle of DC motor is very simple. We can see that when the current conductor is placed in magnetic field, it experiences some force in particular direction. The very basic construction of a DC motor contains a current carrying armature, which is connected to the supply and through commutator segments and brushes. The armature is placed between north and south pole of a permanent or an electromagnet and elementary model. One single turn of conductor is placed between two opposite poles. If we start to supply DC via commutator system, current will start to flow. As we see, positive terminal of the battery is connected to left conductor of a turn, and negative terminal is connected to right conductor of a turn. As we see in model, north pole of the magnet is placed.
So what did you see? This is a north pole, south pole. And can you see a circular object? Can you see a circular object? Yes or no?
Yes, sir.
What is the circular object? It is called commutator. It is called commutator. What is commutator?
Commutator.
Commutator, what does it? It is actually, you think for an example, let this is not there. This is not there. So immediately without the commutator, this basically commutator is basically what? It is providing a contact with the wire. The wire is not rotating. The wire is rotating, but this part is not rotating. Which one? This part. This part is not rotating. Understood? The wire, if this is not there, what will happen? When the armature rotates, this will also turn the wire, and you will break the circuit because it is like you take a rope and you start rotating. What will happen? The rope will become what? It will get turn, and the whole circuit will get destroyed. Understood? But the thing is that this wire is connected to this carbon brushes, and the carbon brushes are creating a contact between this wire and between this. So this wire is fixed. This will not, because of this commutator, the current is always flowing in this direction. Which direction? This direction. And continuously, this is downward direction, this is upward direction. After it goes that side, again the downward direction, upward direction. Otherwise, if this commutator ring would not have been there, then what will happen? What would have happened? You know, the armature would have gone this way, that way, this way, that way. मतलब ये A B है ना, तो next cycle में ये हो जाएगा, B A हो जाएगा, फिर से A B हो जाएगा. Rotation नहीं होगा. It will just flip and again come back, flip and come back. But we don't want that. We want rotation. It should go this way. Continuously it should rotate. Because of this commutator, it is possible. If you don't have commutator, then what will happen? It will only go this way, that way, this way, that way. Is it clear?
Yes, sir.
Is it clear? Proof clear?
Yes, sir.
So let us see the complete demonstration.
Left side and south pole is placed near right side of the turn. Current in left side flows inward, and current in right side flows outward. As we see, conductor is carrying current and they placed in magnetic field. Both of them experienced mechanical force acted on them. Direction of mechanical force can be easily determined by applying Fleming's left hand rule. To do this, spread out your left thumb, forefinger, and second finger so they are all at 90 degrees to one another. With that, if the forefinger is aligned along direction of magnetic field from North Pole to the South Pole, and second finger is aligned along direction of the current and left side conductor, then thumb indicates direction of mechanical force. Similarly, if the forefinger is aligned along direction of magnetic field from North Pole to the South Pole, and second finger is aligned along direction of the current and right side conductor, then thumb indicates direction of mechanical force. Due to this upward and downward forces on the turn, one torque is produced when turn rotates on clockwise direction as shown. After rotation of the turn comes to vertical position in respect of the magnetic field. At this position, there is no current in conductor because turn, conductor, and brushes rest between two commutators. Hence, there is no force acting on conductor by due to moment of inertia. Turn continue to rotate and come.
मतलब वो क्या बोल रहा है? What did you see? Can you see some gap here? Guys, can you see some gap here? Can you see some gap here?
Yes, sir.
मतलब
Yes, sir.
when this conductor
Yes, sir.
armature is in vertical position, here this one is here. Beware. मतलब this will go up and there will be no contact between the carbon brushes. That's why the current will cut off. Current will get cut off. But you say, sir, if the current is getting cut off, then how it will rotate? Because moment of inertia. What is moment of inertia? When you are running, suddenly you stop. You continue to go. Yes or no? Because of the moment of inertia. When the bus is traveling, suddenly the brakes are applied. So what will happen? You also try to go with the bus. Yes or no? For some time you get thrown upward. Why? Because of the moment of inertia. So because of the moment of inertia, the vertical armature continues to rotate, and again the current will touches, again it start rotating. So only when the vertical position, when it is here, there is no current acting on the coil. But Because of the moment of inertia, the coil does not stop rotating, it rotates. Is it clear to all of you?
Yes, sir.
is horizontal again. Position of conductor has been changed here. That means conductor, which was previously in left position, comes to right position, and which was previously in right position comes to left position. At that position, we can determine mechanical force with applying Fleming's left-hand rule. Let's do that. To do this, spread out your left thumb, forefinger, and second finger so they are all at 90 degrees to one to another. So if forefinger is aligned in direction of magnetic field, that is, from North Pole to South Pole, and second finger is aligned in direction of a current in the left side conductor, then thumb indicates direction of mechanical force. This is clearly upward here. So if forefinger is aligned in direction of magnetic field, that is, from North Pole to South Pole, and second finger is aligned in direction of the current in the right side conductor, then thumb indicates direction of mechanical force. This is clearly downward here. Do this upward, and downward forces tend to rotate in clockwise direction. From that explanation, we can come to the conclusion that here in this model, we can see that whichever conductor comes near South Pole experience upward mechanical force, and near North Pole, downward mechanical force. And do this continuously forces mechanical turn rotate, even if battery is not connected. Particularly DC motor rotates at the same principle like this elementary model. Instead of single turn in DC motor, we have mountain turns on major coil. And instead of 2 poles, there is number of poles.
Guys, clear or not? Did you understand the concept?
Yes.
The main concept is Fleming
Yes.
left-hand rule. Or kuch nahi hai. Fleming left-hand rule, current is, you are providing current. As long as you're providing current, the motor rotates. Immediately when you stop, motor will stop. It is like fan. You switch on the fan start rotating. But when you switch off the fan, can you tell me whether the fan stops immediately or after some time it stops? Huh? When you switch off the fan, does the fan stops immediately or fan takes time to stop?
Sir, it takes time.
Why? For what? Because of moment of inertia. Understood? Understood?
Yes, sir.
Yes, sir.
So we have a little left on this. In the next class, tomorrow's class, we'll study about that formula. What is the torque value? It is NIA B cos theta. We will study, we'll derive this, and we will study more about that. With this electric motor, it's a very important question in your exam. So I'm taking a little time. I don't want to hurry. Okay, so whatever has been studied, please study tomorrow and come back to the class because we will go ahead. More advanced topics we will go. Is it clear?
Yes, sir.
Chalo. Good night. See you tomorrow at 8 o'clock.
Sir, we are
Right,
having
sir.
class on Tuesday and Wednesday, right?
Next week we have class on Monday and Wednesday. I told you, no? Just now.
Okay, okay. Sure.
Yes, sir.
See you.